Hello guys, welcome to my workbench again. I've been off for a while and I didn't finish that project of the towers yet. Momentarily are so bad conditions, so I can't make any QSO, so I didn't test the towers either, for that matter. But having said this all, and this is my new project, and as perhaps somebody who's interested in making a regen receiver, and perhaps it is interesting for you or not. If you like it, you give me a thumbs up. Well, I will go through the parts we need for making that regen, and then I will go in specific detail of making that regen. Don't be alarmed, everybody can do it if you have a bit experience in building or whatever. So it is a very simple project, and again, not a very simple project, it depends how you look at it. Anyway, we have here to make our chassis, or the box where we put it all in. I found some material, aluminum, where I can make that up. See, if you put it on the side, that will be high enough to get the parts underneath, so it is on top of it, so it should be okay. So what we want to do is put it on there, that's right. Put for instance the transformer here, and the output transformer. See, I have two parts I mentioned already, and we have a speaker here. I will tell you this is so look, 5200 ohms, 5.2K, 5.2K is that, and it is an output from 3 to 5 ohms. So an actual speaker from 4 ohms, like this one here, will do nicely. So that's, having said that already, I have to show you this. I made this transformer a while back, and I wanted to put in there 235 in and 235 out, and there's nothing left on there because I want the separation transformer, something like that. So I'm not going to use it like that. So, but I can use it for this small receiver, and use that. I will take the metal out again, and then I will put the heater windings on there. So for the valve. So I have to do that. I will do that on camera. I won't bore you with that. So I will do that, and we'll come back to you, and it will be done. There's nothing to report on that either. So then what valve we're going to use? We're going to use an ECL82, or actually it is a 8BM8. There's a triode and I'm not sure. Have a look. Hold on. There's a pentode. There's an output pentode, and the triode we will use for the high frequency or the RF, and the pentode will be our AF amplifier. So it's not very exciting, it's quite straightforward. Then we have our tuning capacitor. The aim is 100 picofarads, and then you're at 3 megahertz. I don't think he is 100 picofarads, so I have to measure it. I have to clean him up also, he's dirty. So I'll use this, probably I will use this capacitor. I have all the mountings. I took it apart to clean it up a bit, and that's separated from the chassis as well, so that's a very nice thing. Well, let's see how it goes, and anyway, to show you which part you need. You need a speaker, you need a transformer, if it is in America with 120 volts 250 and 6.3 for the filament. You need an output transformer 5.2K and with 4 ohms or 8 ohms, depending on the speaker you're going to use. You need an antenna connector, and you need a coil. That's the interesting part. This coil is 5 centimeters in diameter, so I think it's a bit more than 2 inches. And there is the wire gauge 19 on there, 25 turns. And as you can see, is at 8 or 9 is tapped. In the previous video I told already when you are making a coil like that, and it will tune from 3 megahertz, 3.3 megahertz to 8 megahertz, something like that. And when you want to tune then 3.5, 3.5, 3.8, 80 meter band, then this tap is in the wrong place. And why I do know that? Because if you divide 8 megahertz over those windings that are there, or those turns, you have 1, 2, 3, 4, 5, 6 turns. So for on 3.5, 3.8 to have the proper tuning, you have to have it on the 3rd turn tapped. So this will be for 80 meters. Actually, I intend to use them also for what do you call it, 40 meters. Well, we have to make them tap through it on there somewhere. The latter part of the video I will come to that. So that will be not 25 microhenry, so that's exactly what this is, 25, because it works out that way. It's just a coincidence. I will tap them a bit lower. What I will do then, I will switch between that part and that part, that tap, to this is 80 meters then, and this will be 40 meters then, because the coil is a lot smaller, the frequency will be much higher, and if you're lucky, we are at the right tap here for 40 meters as well. Don't hold me to that. I probably have to reconsider that. There's 1/3, 40 meters. It will say it is 20. 1/3. 20. That will be about 6 turns. So 6 turns on 7 megahertz. It depends how high it goes up. I'll have to dip it, we know for sure. I suspect it will be something in the region of 20 megahertz. Then you can see you have to make another tap as well for 7 megahertz. So that's not a very difficult part to take another turn, but if it is on one turn, we won't bother, so we leave it as it is. So the only you have to do then is switch between the tap and the top of the coil. So I hope you understand what I mean. So well, you can see that in the latter of the video. So anyway, you can in advance make that coil. It's not very difficult. It's just drain pipe, what you can buy in the building market. So you can take a piece. What will that be? Let's have a look. There's a 70 centimeters is a bit, about 3 inches. Then you can mount it like that. You just make sure that you are 1 centimeter or say 1/2 inch, a bit more than say 3/4 of an inch above the metal, so you don't have any influencing from the plate. So anyway, that's so far. We have another some minutes on there already. So what I want to do with this video is to go step by step, so you can follow along. And if you are able to get an idle transformer like that. You could do this with a 6.3 transformer, 122 transformers, you can do that. So you could make one of 6.3, 6 volts, so for the filament, and the same tap you can use for the other transformer to transform them up to 120 volts. So that is possible. That's possible also for 235. So you can do that. This is no problem. If you have 2 transformers, no problem. That will work. Well, you need some diodes to rectify the lot, yeah, and some capacitors, electric capacitors from 47 microfarads, something like that. Take 2 of them, make sure that it's straightened out properly, so you have no hum. And there you go. That's what I have to say for now, and we'll see. And I think it will be a nice project. And it will work perfectly on 2 bands. So we need another switch to switch the coil, and we do something on band spread, I suppose. I've done that on other receivers as well. It's not that difficult. There is a video on my channel that explains that a little bit. So it is quite easy to do that, because you probably don't need the whole capacitance of that tuning capacitor. So you can put that one on here. That's a coincidence. In series with it, you can do that. If you put that one in series, that is the same thing if you are putting two resistors parallel. That works the same way, only this is in series. That a resistor is parallel, and for a capacitor is in series, so it is not that difficult. So you can work out your minimum capacitance and your maximum capacitance, and just depending on that little capacitor here, how much this is going to tune. That is that simple. It's not rocket science, it's simple things. So guys, I will put this little video on the net. If you like it, give me your thumbs up. Don't be discouraged by all the things we see on the bench. You can follow along and build it yourself. Mind you, if you work with high voltage, be careful. Don't get yourself zapped. You do that on your own risk. I have to mention this. You do that on your own risk. But if you keep your hands in your pocket, one hand in your pocket and the other hand on a knob, then nothing will happen to you. So, well, I will clarify this a little bit further. So, I intend to put it on a wooden plank or something like that, so that you don't have to. See, you have the front also. Perhaps you can make that from this material here. I don't have that. You could make a front of that one, so that will be insulating. You can use wood as an insulator. But there again, we have a short transmitter here, so we have to be careful. I have to think about how we're going to avoid to have a transmitter instead of a receiver. So, but there again, it is again well close to oscillation. So when this receiver works, so that was the reason in the early years you're not allowed to have one of those receivers, because they put an RF signal out on the air, and that was not allowed. So again, I hope you enjoyed this little video. And as you can see, I'm full at it again. So let's hope this works out, of course. I'll see you in the next video. As I said, if you like the video, give me a thumbs up, and I will give you all the details. I will give you even a schematic to work with. And I'm sure this works. But in the earlier years, That was a long time ago. I built this kind of receiver with this valve, and it was on the broadcast band, and that worked as a Jemima. It really was good. Worked very well. Anyways guys, I stop the video and I'll see you next time.